Okay, the special right triangles videos I'm going to split up into two, one dealing with the 45, 45, 90, and one with the 30, 60, 90. The first section here, I'm going to go through pretty quickly. With a 45, 45, 90 triangle, we start off with a square, okay? And it's going to ask us here to, suppose the side length is S, we're going to draw in diagonal AC inside the triangle. So we're going to go from A to C and draw the diagonal. What's going to end up happening is we're going to be cutting this triangle completely in half. The first bullet point asks us to list the angle measurements for triangle ABC and for ADC. Well, we already know that angle B and angle D are 90 degrees. With a square, a property that it gets from the rectangle is that we have 90 degrees. A property it gets from the rhombus is that the diagonal will bisect or cut in half the angles. So angle A has been cut into two 45-degree measurements, and so has angle C. So now we wind up with two 45, 45, 90 triangles. And this is going to be the basis of what we're doing with this section in this video. Now, the two bullet points here are going to be using Pythagorean theorem. I do not recommend it because it can get a little tricky. I'm going to go through it pretty quickly because what we're going to be learning to do is not use Pythagorean theorem, but use a table and proportions with 45, 45, 90 triangles. Okay, so the first one's saying, suppose that the side length of the triangle is 5. So if the triangle side length is 5, all four sides are 5. And we're going to use Pythagorean theorem to help us find the hypotenuse of the 45, 45, 90, or the diagonal of the square. Right here. So our Pythagorean theorem of a squared plus b squared equals c squared. Please pause the video at any time, okay, to get everything jotted down. A and b are going to be the two legs, which are both 5. So we're going to plug in 5 squared plus 5 squared equals c squared. First step in Pythagorean theorem, square the two numbers given. The second step is either add or subtract, depending on what we need. In this case, we're going to add them to 50. And the last step in Pythagorean theorem is always going to be to take the square root. Now, at this point in my geometry classes, we no longer plug in the square root of 50 into the calculator. We need to actually simplify them. The square over here is going to cancel. And the way I do these simplifying your radicals is I build a division tower. Starting with the smallest prime number, keep dividing until you cannot anymore. And then if we can't divide by 2 anymore, which is the smallest prime, we move up to 3, then 5, then 7, etc. Here we can divide by 2. We're going to get 25. Then when we have 25, we're going to see we cannot divide by 2 anymore. We move to the next prime number of 3. We can't divide by 3. The next prime number 5. We can divide by 5. We get 5. Once you have a prime number at the top of the tower, you're done dividing. So we're going to go ahead, here's my division house. All your partners are going to come together as a single number, in this case 5. And then the single numbers, they're going to come together as 1, 5 on the outside of the radical house. And then anybody that does not have a buddy goes inside the radical house. And your answer is 5 square root of 2. With the next problem, we're given the hypotenuse. Don't get hung up too much on what's happening on this problem because we're going to learn the other way of doing this with the proportions. The hypotenuse is now going to be 10. So in a squared plus b squared equals c squared, we're going to have 10 squared on the right side. Now, I'm going to go ahead and erase these so we're not looking at 5s anymore. The two legs of a 45, 45, 90 coming from a square are exactly the same thing. So if one leg is x, our unknown number, or s, I'm going to use x so it doesn't look like a 5. Our other leg is x. So now we can still use Pythagorean theorem because we have x on both legs. So for a squared and b squared, we have x. Just as if this did not say a square on it, x squared plus x squared, how many x squareds do you see? 2 x squares. And then I'm going to go ahead and square that 10 to get 100. So I guess Pythagorean theorem is not always those 3 steps I mentioned earlier. Now again, with just as if this said 2x, we would be dividing by 2 on each side. Please make sure you bring down that x squared, not just an x, and this will be x squared equals 50. Then the last thing we get rid of is that radical, square root. Now it's not cheating if I already did the work up here, okay? But up here I see I've already done the simplified square root of 50, and we found it came out to 5 square root of 2. Now what we're going to be looking at here is on the 45, 45, 90 triangle, we already know that we're going to have 2 congruent sides. And as we learned with isosceles triangles, the isosceles triangle theorem and the converse, if we have 2 angles that are congruent, across from them, we're going to have 2 sides that are congruent. In these, with the special right triangles, we use the letter A to represent just the missing side, and we'll see on the next video where A will go. And what happens is, on the 45, 45, 90, the hypotenuse is the square root of 2 times the leg. So if we're going to do the square root of 2 times the leg, well, the leg is A, we do times the square root of 2. Okay? Just like with an X and a 5, we place them next to each other. We cannot physically multiply them. This right here, if you search my YouTube channel for 45, 45, 90, I can show you another way of using the A, and A square root of 2. My favorite is the proportions, and that's what I'm going to use. Okay, with your 45, 45, 90s, there's a table that you need to know that you can use for proportions every single time. This is what the table looks like. This is going to be your 45, 45, 90 table. I want you to use this table as your quote-unquote formula for every single problem. 3 columns, 2 rows. This is what you write first, okay? Also notice they only gave you 145. You need to automatically know the other angle is going to be 45. They'll give you the 90, and they'll give you one of the 2 acute angles. What happens now is you ask yourself, what do I have and what do I need? Well, they're going to ask you both for AB and AC's length. Okay, well, we just talked about how we have 2 congruent sides. Both of our legs are going to be the same. So what I want to note here is that when finding AB, AB is equal to BC. They are congruent. Therefore, their measurements are equal. And BC was 9. So we have already found one of our 2 sides. We only have to solve for one of these. Now, if I go ahead and plug this in as X for our hypotenuse, what we're going to do is, what do I have? What do I need? I have the 9. The 9 is across from the 45. So in the middle 45 column, I'm going to put 9. And there's a reason I'm doing it in the middle column. We don't need to fill it in for both of them. The 45, 45, 90, we're only going to focus on the middle and the right column. What do I need? X. It is across from the 90 degree. So X will go here. Now what we can do is we can look at our proportions. Fraction bar equals fraction bar. We have here 1 over 9 equals square root of 2 over X. When we do our cross multiplying, this becomes X. And we discussed earlier with the 9 and the square root of 2, we don't put those in the calculator. That's just if it was a number and an X, you have to place them right next to each other as whole number first, square root of 2, that radical comes second. And this is your answer. The shortcut is on a 45, 90 only. If I give you a leg as a whole number, slap a square root of 2 onto it. Let's take a look at the next one here. First, I'm seeing 45. I know my other angle's 45. Let's go ahead and write in our table. Go ahead and pause it and draw it in. Now, we're looking for AB and BC. Well, AB and BC are the 2 legs. So we only have to solve for one because AB will be equal to BC. Solve for one, we have both the legs. Okay, what do we have? What do we need? We have 4, which is across from the 90, so 4 goes under the 90. We need the leg, so it doesn't matter which one we put X for, we're looking for what's across from the 45. Again, I'm just going to ignore that first column, we only need one of them. Now we can set up our proportion. Fraction bar equals fraction bar. 1 over X equals the square root of 2 over 4. Let's go ahead and get started with our cross multiplying. With this cross product with the X and the radical, What we want to do is we want to place the x first, then the radical. Generally, this is how you see it. It's okay if you do square root of 2x, but this is generally how we'll see this. We set it equal to 4. Now, what we're going to do is we need to divide by what's attached to x. What is attached to x? The square root of 2. So let's divide both sides by the square root of 2. It will cancel on the left. What we have learned with radicals is red flags should be going off. You are not allowed to have a radical in the denominator. We have to do what's called rationalize. We got to get rid of it. Now, the way I teach students is a shove it and leave it method. The shove it, okay, first of all, we're having to fix the denominator so the numerator does not change. Just bring that 4 over. Shove it, we're going to shove that radical to the top. Leave it, we're going to leave the radicand, the number under the radical house, as a whole number in the denominator. But we are not done. We have to remember our dividing. We are able to divide 4 by 2. So our final answer, 4 divided by 2 is 2. We get 2, don't forget your radical, square root of 2. All right, our next problem here, we're going to be looking for A, B, and BC. We're going to notice A, B, and BC are the legs. So AB is the same as BC. So we only have to find 1. So what do we have? What do we need? What do we have is 3. It is across from the 90. It goes in the 90 column. What do we need? The legs. And they're both across from the 45, so we can just place our X in that middle column like I mentioned earlier. Now we can set up our proportions. Fraction bar equals fraction bar. And you can even do this right in the table if you're able, if it's big enough and legible enough here, okay? Watch, cross multiply. And we just saw this on the previous problem. It's going to look a little different, but okay, we took these and we just placed them right next to each other. So we have x square root of 2, set it equal to 3 times 1 is 3. We discussed, just as if it said 2x, we need to divide both sides by what's attached to x. We'll divide both sides by the square root of 2. And we're going to see red flags, radical in the denominator. We need to get rid of it, shove it, and leave it. Bring your numerator over. Shove the radical to the top. Leave the radicand, that 2 under the radical house, as a whole number in the denominator. Now, we cannot divide 3 by 2 evenly. We will get a decimal. The whole point of leaving it with the radical is we don't have decimals in our answer. So therefore, we are done. Your answer is 3 square root of 2 over 2. Okay, let's take the next one. I'm going to go ahead and draw in the table. Okay, and we're going to look for AC and BC. Well, AB and BC, they're the same thing. Again, like the first one we did. Here, sorry, rewrite that. We're looking for BC. It's going to be the same as AB, right? So therefore, AB is 2 square root of 3. We already found the missing leg. The hypotenuse, I'm going to go ahead and label as X. This is the one we're going to go ahead and solve for. What do we have? What do we need? What do we have? 2 square root of 3. It is across from, ooh, I forgot to label this with a 45. Let's go ahead and get that in there. 2 square root of 3 is across from the 45. What do we need? X over here is across from the 90. Fraction bar equals fraction bar. Here are proportions. Start here. X times 1 is X. Now, when we take a look at the other cross product, we have 2 square root of 3 times the square root of 2. When multiplying our radicals, we need to remember what I call apples with apples, oranges with oranges, whole numbers with whole numbers. Here's a 2. Oh, there's nothing to multiply 2 with, so bring it down. Oranges with oranges, radicals with radicals. Square root of 3 times the square root of 2 is not 6. It is the square root of 6. The square root of 6 cannot be simplified. Even if you wanted to go test that out, divide by the smallest prime number possible, you get 3. There are no pairs. This means we're already simplified. Your hypotenuse is 2 square root of 6. Now the next two problems are going to bring back that square at the very, very beginning. We're either going to be given the diagonal of a square or have to find the diagonal of a square. What we want to do in this case, we're looking for we are given the length of the diagonal. We want to find the length of a side. So the first thing we're going to do is we're going to draw in our square. Go ahead and draw in a square. And I've gone one step further and made sure to label my 90 degrees and my congruent sides like we saw on at the very beginning of the video. Now we have to draw in the diagonal and label it with 8 square root of 2. At this point, we're done with the square. We are now looking at this 45, 45, 90 triangle. So what we're going to do is exactly what we were doing in these previous problems. We're going to go ahead. We have a 45, 45, 90. We're going to set up our table. I won't worry about pausing it. Just set it up with me. And notice how I'm setting it up. One row at a time. 45, 45, 90. 1 square root of 2. Okay, what do we have? 8 square root of 2 across from the 90 goes in the 90 column. What do we need? The legs, which are both the same, okay? And those are across from the 45s. Again, I'm just using the middle column. Now we have fraction bar equals fraction bar. There's our proportion. With our x, we're multiplying with the square root of 2, so we have x square root of 2 equals, then the other cross product, anything multiplied by 1 is itself. Now what's going to happen is, okay, we already went over a couple of these. We need to divide by that radical attached to x. And what changes here is not only is it going to cancel on the right, but we got lucky. It cancels on the left also. X is 8. All right, last problem for 45, 45, 90. Okay, the perimeter of a square. All right, let's go ahead and draw on a square real quick. Just like before, I made sure to put my 90 degrees and my congruent sides. The perimeter of the square is 40 centimeters. We're going to find the length of the diagonal. Okay, first of all, we need to see perimeter is 40. We are finding the length of the diagonal. Let's go ahead and draw on our diagonal. With that diagonal, that's going to be our x. Remember, we have created 245 degrees. So we can just now focus on our special right triangle. The perimeter is 40. Do not label a side 40. The perimeter, big P, is 40. On a square, all 4 sides are congruent. So we need to take that perimeter 40 and we need to divide it evenly amongst the 4 sides. And we're going to find out that each side length is 10. Now we can start with our table. Let's go ahead and quickly draw in that table. 45, 45, 90. Second row is 1 square root of 2. What do we have? What do we need? Well, we have the side lengths, the legs, the side lengths of the square, which are the legs, which are across from the 45. Again, you don't need to worry about filling in that first column. Okay, I'm not going to use it. What do we need? X, which is across from the 90. Okay, taking a look at the middle and right column, fraction bar equals fraction bar. Here's our proportional setup. 1 over 10 equals, actually I'm just going to do it right in here. Yeah, we got 1 over 10 equals the square root of 2 over x. I'm just going to go ahead and do the cross multiplying in the table. Here we get x. Over here, again, apples and oranges, we cannot multiply them. So we simply place whole number 10 first, followed by the radical. Your answer is x equals 10 square root of 2. Again, if you search my YouTube 45, 45, 90, I have 2 other videos. One says using proportions. It's these exact same problems. But if you find the one that does not say proportions, it will show you an alternative way of solving 45, 45, 90, not using proportions if you are interested.